What we're going to look at today is factoring a trinomial into the product of two binomials. A trinomial in the form ax squared plus bx plus c is called a quadratic trinomial. Ax squared is called the quadratic term, bx is called the linear term, and c is called the constant. So we will look at a procedure today called the trial and error method for factoring quadratic trinomials. The first thing you need to do is to look at your trinomial and see if there are any common monomial factors. Here there are no common monomial factors in the trinomial x squared plus 5x plus 6. So you don't have to worry about that in this particular instance. Then we're going to determine the factors of the quadratic term. Well, my quadratic term here is x squared, and the only way that I can factor x squared is x and x. So if the coefficient for your quadratic term is 1, then that simplifies things tremendously, because that factors into simply x times x, which is x squared. So determine the factors of your quadratic term, and these will be the first term in each of your binomial factors. Again, what we're trying to do is factor a trinomial into the product of two binomials. The next thing we're going to do is determine the factors of the constant term. Remember, this is the quadratic, x squared, this is the linear, 5x, and this is the constant. Now we have two factors actually here that we can consider for 6, and there are 1 and 6 and 2 and 3. Now we're going to cut down somewhat on our number of trials by looking at the sign of our constant term. If the sign of your constant term is positive or plus, then the signs of your two binomial factors will be the same. So the two signs that I have here will be the same if the constant term is positive. And we can do a little bit better than that. We know that those signs will both either be plus or minus. Keep in mind that a negative 2 times a negative 3 or a negative 1 times a negative 6 will still give you a positive 6. So we know that both of these will be plus or both of these will be minus. But if the sign of the constant term is positive and your linear sign of your linear term is also positive, then that tells you that your signs will both be positive. So I know that this will be plus, and I know this will be plus. So the sign of your two binomial factors will be plus if your constant term is positive and your linear term is also plus or positive. So now all I have to do is determine the factors of 6 such that the sum of the outer and inner products gives me the linear term, which is 5x. And that's why we call it trial and error, because I don't know if the factors that of 6 that I'm looking for here are 1 and 6 or 2 and 3. So that's why we call it trial and error. But the factors that we're actually looking for 6 would be 2 and 3. Why? Because that would give me an inner product of 2x, and then give me an outer product of 3x, and the sum of those gives me the linear term, which is 5x. Next example, very similar to the first in the fact that our quadratic term still has a coefficient of 1, which makes it relatively easy to factor. Constant term is still plus 6, but what has changed here is the sign of our linear term. So again, what we want to do is take this trinomial and factor it into the product of two binomials. So again, before I start, I'm going to check to see if this polynomial contains any common monomial factors, and it does not. So then I begin directly by factoring the quadratic term. And again, the factors of x squared are simply x and x, because x times x is x squared. Then I need to determine the factors of the constant terms such that the sum of the outer and inner product of the two binomial factors is equal to the linear term. And again, I have some hints here. The constant term is preceded by a plus. So that means I'm going to have like signs in my two binomial factors here. So either they're both going to be plus, plus, or both going to be minus, minus. Now, my linear term here is preceded by a minus sign. So if the constant term is preceded by a plus sign and the linear term is preceded by a minus sign, I'm going to have like terms, but they're both going to be minus. And again, I call this trial and error because now I've got to determine the factors of 6. The factors of 6 are, again, 1 and 6 and 2 and 3. But I need to choose the factors of 6 that go in my two binomial factors such that the sum of the outer and inner product will give me a minus 5x. So the factors of 6 that will accomplish that are 2 and 3. A minus 2 times x is minus 2x, and x times a minus 3 is a minus 3x, and that gives me the linear term, which is minus 5x. Now again, what you want to do is to check this to make sure that you have factored this trinomial into the product of two binomials that gives you what you started with. So again, just a quick check to see that we factored that correctly using FOIL. First times first is x times x, which is x squared. And we've already determined the inner product here, which is a minus 2x, and the outer product, which is a minus 3x, and the sum of those two gives me minus 5x, which is a linear term. And of course, the last times the last, negative 2 times negative 3 gives me positive 6. So always check the product of your two binomials to make sure that it gives you the original trinomial that you started with. In the previous two examples that we've taken a look at, the sign of our constant term was preceded by a plus sign. And here the sign of our constant term is preceded by a minus sign. So again, our goal is to take this trinomial and factor it into the product of two binomials, which is equal to the original trinomial that we started with. First, again, we also look to see if this trinomial contains any monomial factors, and it does not. So I will go directly into factoring the quadratic term. And again, here the coefficient of your quadratic term is 1, so that simplifies our factoring process somewhat, because the factors of x squared are x and x, because x times x is x squared. Now we need to determine the factors of the constant term so that the sum of the inner and outer products of our binomial factor is equal to our linear term, which in this case is equal to minus 5x. Well, a hint here, if the constant term is preceded by a minus, then you'll have unlike signs. One will be minus, and one will be plus. And again, we've got to choose the factors of 6, actually minus 6, so that could be minus 1 and positive 6, or it could be positive 1 and minus 6, or it could be minus 2 and positive 3, or minus 3 and positive 2. So that's why we call this process trial and error. So if we look at the factors that will give us what we want, the 6 has to go here, and the 1 has to go here. remember, the sum of the inner and outer product must give you your linear term. So minus 6 times x is a minus 6x, and x times positive 1 is plus x, and a minus 6x plus x is a minus 5x. And again, what you want to do is make sure that you check the product of these two binomials to make sure that they're equal to the original trinomial. So using FOIL, first times first, x times x is x squared. And of course, the inner product here we've already done, that's minus 6x. The outer product we've already done, that's plus x. The sum of those two gives us minus 5x. And the product of the last times last gives us minus 6. Negative 6 times positive 1 is minus 6. Again, we're looking at factoring quadratic trinomials by the trial and error method. And in the next couple examples, we're going to take a look at trinomials which are more difficult to break down into the product of two binomials. And the reason that I say that it's more difficult is that in the ones that we have done previously, the coefficient of the quadratic term had been 1. So the factors of the quadratic were simply x and x. But here I have multiple factors for the quadratic term. I could have 1x and 12x. I could have 2x and 6x. Or I could have 3x and 4x. So I have multiple choices for the factors of the quadratic term. Which are the correct choices? I don't know. That's why we call this trial and error. We also have multiple choices for the constant term, factors of the constant term, 1 and 10, 2 and 5. So I don't know which combinations will give me the correct factors of the binomial that such when multiplied together will result in the original trinomial. But I do know that since the constant term is preceded by a plus, that I have like signs. That means that the signs that separate my two terms of my binomial factors will both be plus or both be minus. And since the linear term is also plus, that means they're both plus. So that helps some. Now, I don't know whether 1x and it goes here and 12x goes here and 2 here and 5 here, or 5 here and 2 here. I don't know whether 2x and 6x goes here and a 1 and a 10 goes here. I don't know. That's why we call it trial and error. So when I have lots of possibilities to test, I like to go off in the margin and consider all the various combinations. Now, I'm going to rule out 1 and 10 and 1 and 12. Now, they come close, and if I write 1x and 12x and 1 and 10 and look at the various combinations, 1x times 10 will give me 10x, and 1 times 12x will give me 12x, and that's 22x. Now if I look at the other combinations, look at these, consider all possibilities. 1x times 1 is 1x, and 12x times 10 is 120x, and that gives me 121x, which was way more than the 23x that I'm looking for. Now, any other way that I pair the 1 and the 12 with the 2 and the 5 is going to give me a number that far exceeds 23x. So I can pretty much rule out the 1 and the 12 and the 1 and the 10. But I still have to consider 2 and 6 and 3 and 4 as factors of the quadratic term. So let's look at 2x and 6x along with 2 and 5. The 2x and 6x are factors of the quadratic, and the 2 and the 5 are factors of the constant. And I need to consider all possible combinations. So 2x times 5 is 10x, and 2 times 6x is 12x, and that gives me 22x. Close, but still not what I'm looking for. But I also need to consider what happens if I pair these two and these two. 2x times 2 is 4x, and 6x times 5 is 30x, and that gives me 34x. So this is not the right choice for the factors of the quadratic term either. So the only other possibility that I have for factors of the quadratic term are 3x and 4x, and the factors of my constant term here is 2 and 5, because I ruled out 1 and 10, because 1 and 10 in any combination here is going to give you a number which is greater than 23x. So let's consider all possibilities. 3x times 5 is 15x, and 2 times 4x is 8x, and the sum is 23x, and that's what I'm looking for. Now, so I've got to place these various numbers here in the correct positions here in my two binomials. Now, remember the 3x and the 4x were factors of the quadratic term. So if you look at your rules over here, you determine the factors of the quadratic term, and the factors of the quadratic term are the first term in each of your two binomial factors. So the 3x is the first term here, and the 4x will be the first term here. So the quadratic factors are the first term in each of your binomial factors. So now I got to determine where to place the 2 and the 5. Now, look back at the combination that gave me the 23x. It was 3x times 5. Remember, the sum of the inner and outer product has to give you your linear term, which is 23x. So in order to get the 23x, I had to multiply 3x times 5. Well, here's your 3x, so that means the 5 has to go here. And I had to multiply the 2 by the 4x. Here's your 4x, so the 2 has to go here. Check it out. The inner product is 2 times 4x, which is 8x, and the outer product is 3x times 5, which is 15x, and that sum gives you 23x, and that's what we're looking for as far as the linear term is concerned. Now, to make sure that this is factored correctly, you really need to check the entire problem by multiplying the two binomials together using FOIL. So first times first, 3x times 4x is 12x squared, which is what I have here. The outer product, which is 3x times 5, is 15x. The inner product, which is 2 times 4x, is 8x, and that combination gives you 23x, which is what I have here as the linear term. And then the last times the last, plus 2 times plus 5 is plus 10, so it checks out. We're still looking at, to factor in quadratic trinomials, some of the more challenging types. And again, I say this is more challenging because there are multiple factors for your quadratic term here. Your quadratic term is 4x squared, and so it's something other than 1. Something other than 1, you just cannot factor x and x. So what are the possibilities here? I could have a 1x and a 4x, or a 2x and a 2x. So I've got multiple possibilities there as far as the factors for my quadratic term are concerned. Now, I also need to look at my constant term here, and the first thing I'm going to note here is that the sign that precedes my constant term is a minus. So that means that I'm going to have unlike terms as far, or unlike signs that separate the terms of my two binomial factors. Remember, if the sign that precedes the constant term is minus, then you'll have unlike signs in your two binomial factors. One will be minus and one will be plus. Now, I have multiple factors for minus 21. They are 1 and negative 21, negative 1 and positive 21, 3 and negative 7, and negative 3 and positive 7. So again, I need to choose the factors of my quadratic term and the factors of my constant term such that the sum of the outer and inner product gives me the minus 8x. Now, I can pretty safely rule these two out, because if I put a minus 21 or a plus 21 in either one of these and I multiply it by either one of these two digits here, I'm going to get a number that far exceeds the range of what I'm looking for here, which is a minus 8. Cannot rule out a 1x and a 4x, however, for the factors of the quadratic terms. So I still need to test a 1x and a 4x with each one of these, and a 2x and a 2x with each one of these to find out which one is the right combination. So again, when I have multiple combinations to test, I like to come out in the margin, and I like to write the factors of my quadratic term. So I'm going to start with a 1x and a 4x, because 1x times 4x will certainly give me 4x squared. So I need to test a 3 and a minus 7. And I need to look at all the possible combinations. So 1x times a minus 7 is a minus 7x, and 3 times 4x is a plus 12x, and that gives me a plus 5x. But I also need to look at these two pairs and these two pair, this pair here as well. So 1x and a 3x gives me a 3x, and a minus 7 times 4 gives me a minus 28x, and that gives me a minus 25x. And you might say, well, what happens if I flip-flop those? I really don't need to test what would happen if I'd flip-flop the signs here, because what's going to happen is I'm going to get the opposite of each one of these creatures here. So I'll get a minus 5x and a plus 25x. So I really don't need to test these separately. If I flip-flop the signs, I know that what's going to happen is the signs here are going to flip-flop. But to show you that that is the case, let's go ahead and test one of them. X times 7 is 7x, and minus 3 times 4x is minus 12x. And you see that gives me minus 5x, which is the opposite of what I have here. And if I paired these two and these two, it would give me a plus 25x. So I was looking for minus 8x, and neither one of these gave me what I was looking for. So obviously I chose the wrong factors for the coefficient of my quadratic term. So I still have two additional factors for my quadratic term. 2x times 2x will give me 4x squared that I need to test as well. So let's write those down. And let's try 3 and negative 7. So 2x times minus 7 would be minus 14x. And 3 times 2 would be 6x. So when I combine those, that gives me minus 8x. That's what I'm looking for. So I don't have to test the other possibilities. Now, so the combinations for the factors for the quadratic term are 2x and 2x, and the factors for the constant term are 3 and minus 7. So I need to make sure that I get those in the right place up here. Now remember that the factors for your quadratic term will give you the first term in each of your binomial factors. So a 2x goes here, and a 2x goes here. Now it does matter where you place the 3 and the minus 7. Obviously, even though your quadratic terms are the same, the signs here are different. So it does make a difference where you place those. So let's look at the combination that gave me the minus 8x. I had to multiply 2x times a minus 7. So that means the 7 is going to have to go here. And I had to multiply 2x times a plus 3, so the 3 goes here. And again, look at the sum of your inner and outer product. A minus 7 times 2x is minus 14x. And a 2x times 3 is a 6x. And that gives you minus 8x. And again, what you want to do is make sure that you go back and you multiply the two binomials together using FOIL to make sure that you got the original trinomial that you started with. So first times first is 2x times 2x, which is 4x squared. The outer times the outer gives me plus 6x. The inner times the inner gives me minus 14x. And the combination of those gives me minus 8x. And the last times the last, minus 7 times plus 3 gives you minus 21. So it checks out. We're still looking at factoring quadratic trinomials, and we're looking at cases which involve significant trial and error. And here's another case in which we have multiple choices for the factors for the quadratic term. I could use 1x and 16x. I could use 2x and 8x. I can use 4x and 4x. Now notice here that the sign that precedes my constant term is minus. So that tells me that I'm going to have unlike signs that separate the two terms in my individual binomial factors. If the sign that precedes the constant term is a minus, then you'll have unlike sign in your two binomial factors. One will be minus and one will be plus. Now again, remember I'm trying to choose the factors of the quadratic term and the factors of the constant term so that the sum of the inner and outer product gives me the linear term, which is minus 62x. Now, again, there are multiple factors here. How do I get a minus 45? I could have positive 1 and a minus 45. I could have negative 1 and a plus 45. I can have 3, positive 3, and a minus 15, or a negative 3 and a positive 15, or I could have positive 5, negative 9, or negative 5 and negative 9. So you see I have a multitude of possibilities here that I really need to check out. Now, I can pretty safely rule 1x and 16x out, because no matter where I put the 1x or the 16x, if I multiply it times one of these numbers here, it's certainly going to exceed the range of negative 62. And likewise, if I use an x and a 16x and I multiply that number 5 or minus 9, it's going to exceed the minus 62 even when I take the sum of the inner and outer product. So I can safely rule out that. And the same for negative 1 and 45 and 1 and 45. So that narrows down some of the possibilities that I must test. So again, when I have multiple possibilities to test, I like to begin with the two factors of my constant term. 2x times 8x certainly will give me 16x squared, and then look at all the combinations that I have left for my constant term. So let's start with 3 and negative 15, and let's look at all the possibilities. So first of all, multiply 2x times minus 15, which is a minus 30x, and 3 times 8x is 24x, and that gives me a minus 6x. Well, that's not what I'm looking for. I'm looking for a minus 62x. Now I need to look at all possibilities, so I need to also multiply these pairs together. 2x and 3 is plus 6x, and a minus 15 times 8 gives me minus 120x, and that gives me minus 114x. And you say, well, I probably should take the 2x and the 8x and use negative 3 and positive 15. I really don't need to do that, because if I flip-flop the signs of these two, what's going to happen is it's just going to give me these two products here, but with the opposite sign. So making this a negative 15 and that a negative 3 and that a plus 15 will give me a plus 6x and a plus 114x. So I've used 2x and 8x with these two, but I haven't used the 2x and the 8x with the 5 and the negative 9. So let's see what happens there. So I have 2x and 8x, and I'm going to use 5 and negative 9. So let's look at all the possible combinations. 2x times minus 9 is a minus 18x. 10x, and 5 times 8x is a 40x, and I add those two together, and that gives me a plus 22x, which is not what I'm looking for. So let's look at this combination. So 2x and times 5 gives me 10x, and 8 times a minus 9 gives me a minus 72x, and when I add those together I get minus 62x. That's what I'm looking for. So I know the correct combinations are going to involve 2x and an 8x as the factors of the quadratic term, and a 5 and a minus 9 as factors of the constant term. Now remember that your factors of your constant term gives you the first term in each one of your binomial factors. Again, determine the factors of the quadratic term. This will be the first term in each of the binomial factors. So you have to be careful where you place these. I need an 8x times a minus 9. Well, I've got the minus here, so I need a minus 9, so the 9 is going to have to go here, and I need an 8x times the minus 9 to get the 72x, so the 8x is going to have to go here. It does make a difference where you place those. And I have a 2x times a plus 5, so the plus 5 is going to have to go here, and the 2x here. You can always test these to make sure that you get them in the right place by finding the sum of the inner and outer product, and then changing these around if you need to. The inner product here is minus 9 times 8x, which is a minus 72x, and the outer product is 2x times plus 5, which is 10x, and that gives me a minus 62x. Make sure that your sign matches the sign of your linear term here. And again, in order to make sure that you indeed have the trinomial broken down into the product of two binomials that gives you the original trinomial, you should check that using FOIL. So first times first, 2x times 8x is 16x squared. Outer product gives me a plus 10x right here, 2x times plus 5. The inner product, minus 9 times 8x, gives me minus 72x, and the sum of those two gives me a minus 62x, which is your linear term, and then the last times the last, minus 9 times plus 5 gives you minus 45, so it does check out. Here we are factoring the trinomial 10x squared plus 70x plus 100. And if you think about the factors for 100, 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10, etc. There are quite a number of factors here, so there's a number of possibilities here that you need to consider. However, we can actually reduce the number of possibilities that we can consider in this particular case because we can factor out a common monomial factor. So anytime you have a quadratic equation that contains a common monomial factor, you need to factor that out, because what it does is it makes the quadratic easier to factor because it reduces the number of trials and possibilities and the combinations that you have to consider. Now, in this particular case, 10, 70, and 100 all contain a common monomial factor of 10, so I can factor 10 out. So that would be 10 times x squared plus 7x plus 10. 10 times x squared is 10x squared, 10 times 7x is 70x, and 10 times 10 is 100. Now, x squared plus 7x plus 10 is a lot easier to factor because now I have less number of factors in not only my quadratic term but also my constant term. And you need to keep your 10. This tells me I'm going to have like signs. This tells me they're both going to be plus. The factors of x squared are x and x. A lot These are the ones we've been factoring. The factors of 10 are 1 and 10, 2 and 5. So again, I need to choose the factors of my constant term here, so that the sum of my inner and outer product will give me a linear term of 7x. So the combination there that I'm looking for is 2 and 5. 2 times x is 2x, and x times 5 is 5x, and that gives me 7x. And of course, if we check this using FOIL, we get this trinomial here. It doesn't matter where you place the 2 and 5 here. Why? Because both factors here are the same and both signs are the same. If either one of these two had been different, or your signs had been different, then it would make a choice whether you place the factors of the constant term. So look at this equation. This is not a quadratic because it's of degree 3. I have an x cubed. However, if you look at this particular polynomial, you'll see that we can factor a common monomial factor out. I cannot overemphasize the first step. Anytime you can factor a common monomial out of a polynomial, you should do so. So each one of these coefficients contains a factor of 2, so I can factor 2 out. But also, I can factor an x out of each one of these terms as well. So 2x times what gives me 2x cubed x squared, because x squared times 2x would be 2x cubed. 2x times what gives me minus 16x squared. That would be a minus 8x. 2 times 8 is 16. X times x is x squared. 2x times what gives me plus 24x, and that would simply be plus 12, because 2x times 12 would be 24x. So again, x squared minus 8x plus 12 is relatively easy to factor. You keep the factor of 2x, and I'm going to break this quadratic trinomial down. This is a quadratic, it's of degree 2. And the factors for the quadratic term are x and x. And notice that my constant term here is positive, so that means I'm going to have like signs. And since the linear term is preceded by a minus, that tells me they're both going to be minus. So I've got to choose the factors of 12 so that the sum of the inner and outer product gives me a minus 8x. So the factors of 12 that would do that would be 2 and 6. And again, here it doesn't make any difference where you put the 2 or the 6. Why? Because these two terms are the same and your signs are the same as well. So it really doesn't matter where you put the 2 or the 6. You put the 6 here or the 2 here. However, if these two terms were different or your signs were different, then it would make a difference as to where you place the 2 and the 6. But in this particular case, it does not. So again, we need to check this to make sure that the sum of the inner and outer product is a minus 8x. So the inner product, minus 2 times 2 is a minus 2x, and x times a minus 6 is a minus 6x, and you take the sum and you get minus 8x, which is what we're looking for. And again, if we use FOIL and multiply these two binomials together, this is what we get. And if we multiply this binomial by 2x, then we would get the original polynomial equation or expression that we started with. Final example on solving or factoring, I should say, quadratic trinomials. And again, we're going to look at the various factors of the quadratic term, 4x squared, which would be 1x and 4x and 2x and 2x. And the factors of 3, well, we only have 1 and 3, so that's not going to be too terribly difficult to break down. Now notice that the the sign that precedes your constant term, it's a plus, so that means you have like signs. And the sign that precedes your linear term is minus, so that means that in this case they're both going to be minus. So I'm going to have a minus here and a minus there. So really, the factors of the constant term that I need to look at are minus 1 and minus 3. So let's look at possibilities here. The factors for your quadratic term are 1x and 4x, and the factors for your constant term, since the signs are alike here and the only factors of 3 are 1 and 3, will be negative 1, negative 3. So let's look at all the possible combinations. 1x times minus 3 is minus 3x, and minus 1 times 4x is a minus 4x, and that gives me a minus 7x. Now we also need to look at this pair of combinations as well. 1x times x is a minus x, and 4x times a minus 3 is a minus 12x, and that gives me a minus 13x. So I get a minus 7x here, and I get a minus 13x here. I'm looking for minus 2x. So obviously this combination that I chose for the factors of the quadratic term are not the magic combination that I need. So now I need to test 2x times 2x and minus 1 times minus 3. So I have 2x times a minus 3, which is minus 6x, and a minus 2 times 2x, which is minus 2x, and that gives me a minus 8x. So that's not what I'm looking for either. So I need to look at the other possible combination here. 2x times a minus 1 is a minus 2x, and a 2x times a minus 3 is a minus 6x, and that gives me a minus 8x. So it's going to be the same as that because these two terms here are the same, so it really doesn't matter. So I've exhausted all of the possibilities using trial and error. So that means that this quadratic trinomial is not factorable. Not all trinomials are factorable. This one is one that's not factorable. So we say that it's prime.